Okay, so these two examples are a bit more advanced and they require you to do calculations with your upper and lower bounds. So a textbook is 2.8 centimeters thick, the nearest 0.1 centimeter. We want to find the upper and lower bound of the height of 20 books. So we've got lots of 20 textbooks and they're all about 2.8 centimeters. And we want to know what's the biggest possible height of all 20 and the smallest possible height of all 20. So your first step is to look at this 2.8 centimeters and work out the upper and lower bound of that length. So 2.8 centimeters to the nearest 0.1 centimeter. But 2.8 centimeters. 0.1 centimeters less is 2.7 centimeters, and then 0.1 centimeters more is 2.9 centimeters. So our lower bound is the middle point of this. So the lower bound of each book is 2.75 centimeters, and the upper bound of each book would be 2.85 centimeters. Okay, so to find the upper and lower bound of the height of 20 books, so the biggest possible height would be if every book was this long, this thick, and the smallest possible height would be if every book was this thick. So we simply multiply these by 20. So our upper bound of the height will be this upper bound 2.85, and we'd multiply that by 20. So the biggest possible height would be 57 centimeters. And then to get the lower bound of the height, we would multiply this number by 20. So 20 times 2.75 is 55 centimeters. So you work out the upper and lower bound of the lengths first, and then you do the calculation. You don't do the calculation first. You do the upper and lower bound first. Okay, so that's about like length and multiplying. This next one's a bit trickier. So length and width of this rectangle are measured to the nearest 0.1 centimeters. We're going to find the upper and lower bound of the area. So to find the area of a rectangle, we would do the length times the width. So first step is to find the upper and lower bound of each of these values. So 4.3 centimeters, 0.1 centimeters less is 4.2, and then the bigger value would be 4.4 centimeters. So just for this width, the lower bound is 4.25 and the upper bound is 4.35. That's for this length. Then we do the same thing for the 8.4 centimeters. The 0.1 centimeters less is 0.1 centimeters more is 8.5, and then less, so the upper bound is 8.45. Then we have 8.3 centimeters, so the lower bound is 8.35 centimeters. So we've got 4.25, 4.35, or 8.35 and 8.45. So for the area, so to get the biggest possible area, I would multiply these two values together. The upper bound of the area would be 4.35 multiplied by 8.45. So two decimal places, the upper bound would be 36.76 centimeters squared. That's the largest possible area. And then to get the lower bound of the area, I'd multiply these two together because they're the smallest possible lengths. So it'd be 4.25 times 8.35, and we'd get the lower bound to be 35.49 centimeters squared. So there's a lot more work involved with these questions, but it's the same idea. Find the upper and lower bounds first, and then work out what calculation you need to do.